Lesson 7, stopping distance, and Lesson 8, reaction time and braking distance. So Lesson 7, stopping distance. What is the stopping distance of a vehicle? It is the thinking distance added to the braking distance. The thinking distance is the distance a vehicle will travel in the time it takes for the driver to react to the fact that they need to stop. The braking distance is the distance the vehicle will travel under braking. Be careful with thinking distance not to confuse it with reaction time, because quite often an invalid answer is given that the thinking distance is the time it takes for the driver to react. That is incorrect. It is about distance. So the distance traveled during the driver's reaction time. What are the factors that affect the stopping distance of a vehicle? The number one factor is speed. The faster the vehicle, the greater the distance it will take to stop. The stopping distance can be broken into two factors: the thinking distance factors and the braking distance factors. The three things which affect the thinking distance are tiredness, drugs and alcohol. You may give examples of individual drugs, it doesn't matter, but that's all you need. And distractions. Again, you may give individual examples, but it is not required. The factors which affect the braking distance are the road and weather conditions. Again, you may give factors such as snow and rain, but you don't need to. It's just simply say road and weather conditions. Or alternatively, the poor condition of the vehicle. Again, you do not need to say specifically poor brakes or anything like that. Just poor condition is sufficient. Lesson 8 is the reaction time. So for the reaction time, what you need to know is a method to calculate reaction time. The typical method is the ruler drop, where you drop a 30 centimeter ruler and simply catch it between your thumb and forefinger and measure the distance the ruler has dropped. Problem with this one, it introduces lots of random error. If you do it 5 times, you'll get 5 different distances dropped. A way to improve that is to use a computer simulation which measures reaction time. For higher level only, we have what happens when we brake. The vehicle slows down. In other words, it decelerates. Since acceleration is force divided by mass, that means if the acceleration increases, so the force of the braking force increases. So therefore the force on the passengers and the driver. So i.e., if you have a large deceleration, slowing down rapidly, you get a large braking force on the occupants of the vehicle. How does the distance traveled affected by both braking distance and thinking distance independently? Well, distance is speed divided by time. So therefore, if you double the distance, you will get double the speed in the same time. This means that the distance traveled is proportional to the speed. So the thinking distance is proportional to the speed, i.e., if you double the speed, you double your thinking distance. Whereas braking distance is to do with the work done by braking, which is the energy which it needs to be absorbed, i.e. the kinetic energy of the vehicle. Kinetic energy is a half mv squared. So therefore, if we double the velocity, so 2v, 2 squared is 4, so doubling the velocity means we've got 4 times the amount of energy, because 2 squared is 4. So when we put this into a distance time graph, we'll see since thinking distance, the distance is proportional to time, it is a straight line through the origin, whereas the braking distance is proportional to the velocity squared, so you get this upwards curve. So in other words, if you double the velocity, you get 4 times the braking distance. Add the two together for your stopping distance, so your stopping distance curve is the braking distance curve added on to the thinking distance straight line. Okay, and that's why the faster you're going, the much greater the stopping distance, because the braking distance is proportional to the velocity squared.